Well, sometimes we'll see graphics like this. Look at all the color here. The winds can sometimes gust to near 50 miles per hour, if not more than that. The map here showing tropical storm force wind gusts in many areas. But wait, how can this happen? Number one, an absence of a tropical storm. And number two, how do we get all these winds in such a broad area? Sometimes we'll get strong winds coming out of thunderstorms, right, in the summertime. But this is broad, right? This isn't just one area that's getting strong winds. This is area wide. Well, let's talk about how this happens. So this is what we call gradient winds or pressure gradient winds. This is happening on a broad scale. So unlike thunderstorms, for example, which would be a very small scale, or a tropical storm, which would still be somewhat of a broader scale, but still a small scale, this is a much larger scale, what we call synoptic scale in meteorology. So let's dive into this a little bit. We have high pressure in this case down to the south and low pressure up to the northeast. Now, the way to look at this map is in Texas, pretend like you're at the top of a hill and you're looking down towards the area of low pressure. Now, another way to kind of conceptualize air pressure is high pressure, there's more air pushing down on you. Low pressure, there's not as much air pushing down on you. Kind of like when you go into an airplane, right? And they pressurize the cabin because as you go up, the air pressure gets lower. So they've got to pressurize the cabin to make sure that, as humans, we're used to a certain air pressure, right? So you can kind of conceptualize it a bit that way. Well, how does air pressure relate to winds? Well, a change in that air pressure is what causes wind on the broad scale. So when you get stuck in between an area of high pressure and low pressure, the stronger that pressure system is, the stronger the gradient or the change, the pressure gradient as it's known in meteorology is. Now, as you look at these black lines, this is what we use in meteorology. If you're a pilot, if you have pilot friends, they've seen these maps before with isobars on them. What does that mean? Isobars are lines of equal barometric pressure. So the closer the lines are together, the windier it is. So again, a change in air pressure is what causes wind. Now, high pressure, you have clockwise clockwise wind flow flowing around it. Low pressure, you have counterclockwise winds flowing around it. So in this case, our wind is coming more out of the westerly direction because of the placement of these various air masses and pressure systems. So you can tell a lot just by looking at this one map. Number one, the lines are very close together, so it's windy, but then you can also tell the direction of the wind based upon the various pressure systems as well. So that, in turn, is what causes wind. Again, it's a change in air pressure, but let me go back to the beginning. Let me go back to this other graphic that we looked at a moment ago. Unlike thunderstorms, where again, that's a totally different process on a small scale, when you get strong winds on a broad scale like this, so strong winds for everyone, often it doesn't have to do with thunderstorms. It has to do with the pressure setup across the country, what we call synoptic or broad scale meteorology. So pretty interesting there. Again, every system is different, but when we watch for strong winds, area-wide, we're often watching for that big pressure difference.